Hello everyone, today I'm going to talk about medical software regulations with software engineering standards. In Canada, medical device includes medical softwares and is regulated by the Health Canada's MDB department, which is Canada's version of the FDA in the United States. And this department classifies the risk levels for the medical devices from Class 1 to Class 4. Class 1 has the lowest risk, which is the potential risk, and Class 4 will be the highest potential risks that can be happened in the device. There are few essential questions that need to be considered before the medical software development. First is, do you need the regulatory approvals for your product to be sold in Canada? If you are Class 1, you don't need any license. Otherwise, you need to apply for the medical device license. And how are you going to test your product? And how are you going to protect your brand in Canada? So here are some essential information that I took from the Health Canada's website. The first term is about the definition of medical device, which covers a wide range of products. Especially it contains a few constructions and restrictions for the medical software. The MDB of the TPD is the national authority that reviews and evaluates the safety level and risk classifications of your medical device and it's in terms of the medical software safety. The TPD ensures that your device, your medical software is properly classified to the desired risk levels, and the effectiveness and the safety and the quality of your medical devices are the key features that the TPD are looking for. So when a company decides to submit application for the medical device or medical software, the application should contain the information that is needed for their medical device classification level. For example, for Class 1, it doesn't need that much information compared with the Class 4 application. If all the information that the manufacturer provides to the TPD and the TPD think and approved those informations, then a license will be issued for that medical device. Health Canada also designed and accepts some international medical device standards and international medical software development guidance, such as the CAN CSAC 22.2, which is a medical software development guidance in Canada, which is also cost around $5 Canadian to $6 hundred, which is cost about 600 Canadian dollars. However, there is a more popular medical software development guidance in the market, which is called IEC 62304. It's the international standard that defines software development lifecycle with requirements. Uh, it, it includes those key features in the software development process. First is the development uh, requirements and the risk management system, the system structure configurations, the problem resolutions and solutions, and software maintenance after the software is released. This document is widely accepted around the world, like in United States, in Europe, Japan, and China, and also many countries accept this document as a proper guidance for developing the medical software. The document follows those principles. Uh, the medical device software requires risk management system, quality management system, and solid software engineering techniques. And critical thinking should be always involved in the development works. And uh, during the development processes, the team should think about the minimum requirements, not the best practice. However, the document doesn't provide a specific software developing model or software development process for the software, so there are only standards and requirements in the document. Here is the contents that in that document. We can see the scope and the general requirement, the SDP, SMP, the risk management process, and those development standard and requirements. Unlike the safety classifications in Canada, which has 4 levels, in the document it only defines 3 safety classification levels, which is Class A, Class B, and Class C. Class A will be considered as Class 1 in Canada, and Class C will be considered as Class 4 in Canada. Here is the flowchart which explains how it defines the classification level. Before the safety classifications, all the softwares is treated as Class C, and after those process, we can see that Class A has the safest features, and Class B is kind of in the middle, that shows it has some risks but not seriously injures to the users. Class C will be, it can cause serious injuries to the users. Now I'm going to talk about software engineering standards. The first thing you need to know is the software process. A software process, also known as software development model, is a set of activities that leads to the productions of the software. So for any software process, it must contain those four following activities: the software specifications, software design and implementation, software evaluations and verifications, and validations, and in the end it will be the software maintenance. The software process model is really similar with the software process activities, but in the models, it defines the development works into each individual development phases, which includes the concept phase, implementation phase, maintenance phase, and all those phases are connect to each other strongly. Now I'm going to give an example of software process model, and this one is a really classical model which is called the waterfall model. This model is the first process model to be introduced to the world. The waterfall models follows the software development process in a linear sequential flow. This means any phases will start until the previous phases is completed. Here is a graph that describes this linear sequential relationship. We can see after software requirements, it goes to project design and so on. Just like the waterfall, those phases follow this relationship. Now I'm going to talk about a key concept in the software engineering standards, which is the software development lifecycle. Also, it's called SDLC. The SDLC includes the software process model. The goal of SDLC is to provide a high quality system and software. So during each phases, the test need to be done first before the next phase starts. In the SDLC, the maintenance cost is also included in the life cycle, so it can provide cost-effective solutions for the software development work. Here is a graph for the better explanations of this concept. We can see requirement, analysis, design, coding, testing, development are listed in a circle. So this shows the procedures in the software development works, and this special relationship of those phases provide a high quality of the software structures and system. In the medical software development document, it includes the quality management system. I'm going to use QMC to introduce it. So the QMS is really important in the whole process of the software development works. The QMS is a collection of all processes and functions that can continue improve the quality of the software to ensure it meets the customer's needs and the company's expectation. It is a framework that organizes the structures of the management in the company, which can provide an efficient way to manage the employees and improve the productivities in the company. It has those benefits, uh, tangible gains in productivity, which can be considered as improve the productivity, increase the effectiveness of the use of the resources, challenging goals and targets that encourage company growth and expansion faster. However, there is a common problem in QMS, which is QMS will and must bring change in the company, and as uh, employees, they also think that the change will across their comfortable zones, so they don't really like and want any changes in the company's system, and this can lead to QMS failures in the company. The solutions is to conquer those human nature weakness, but it's not easy. So the most effective way is to do more effective communications in the company. So the managers should communicate with their employees in an effective way in order to solve this problem. So in the medical software development, the ISO 13485 is the document that for the medical software and is an international recognized standard. The goal of this document is to provide the harmonizations of the medical device regulatory requirements for quality management system to ensure the product has a high quality that meets the customer's need and the company's expectations. In Canada, the ISO document is a mandatory requirement for the applications of Class 2, Class 3, and Class 4. So if a company want to apply for those licenses, the company need to get the approvals of these ISO standards first, so they can continue the applications. In the ISO documents, the basic requirement is that the manufacturers should document a quality QMS and maintain its effectiveness and safeness of the products for the international standards and the regulatory requirements. The documents only contains the requirements and standards. It doesn't provide any specific solutions for certain problems. So the companies need to consider whether their solutions meet the requirements in the document. The risk management in software engineering means high-quality solution systems that protect the potential risks in the software development. Usually, it includes those tasks: identify risks and their triggers, classify and prioritize all risks, build a plan for those risks, monitor the risk triggers, and communicate risk status throughout the project. Here are the 5 types of risks in the software development works: the new unproven technologies, the functional requirements, the system architecture, the performance risks, the management risks. The new technology risks will be the risks that the team decide to use new algorithms or new development frameworks, and there are a lot of potential risks in these new technologies. The functional requirements will be the risks that exist in when the software is running, like some logical errors that can lead seriously damages to the device or seriously injures to the users. Those risks can be considered as functional requirements risk. The application and system architecture risks will be the risks that exist in the system architectures, and those risks can crash the whole system or can stop the software running. The performance risks usually means some risks that can slow down the software running efficiencies or stop the software working properly. The organizational risk usually means the risk exists between the managers with the development teams and the expectations of the customers. In those relationships, there can happen a lot of risks that make the software doesn't meet the customer's needs and the company's expectations. And those are the references that I have researched for this presentation. And thank you for watching this presentation.